Does the universe have a defined shape? This audiobook explores one of the deepest mysteries of cosmology, the geometry of the cosmos. Is it flat like an infinite sheet, closed like a giant sphere, or curved like a cosmic saddle? Through modern physics and the most precise observations, we will discover what the shape of the universe reveals about its origin, its destiny, and our place within it. The search for answers about the universe leads us to question its origin and structure. How is it possible that something so vast and complex like the cosmos originated from a single point billions of years ago? The history of the universe is like an epic tale that unfolds on an unimaginable timescale, where each star, each galaxy, and every corner of space tells a part of the narrative. On this journey, we will delve into the concept of the observable universe. Imagine you are an explorer in a vast jungle. As you venture in, you realize there are boundaries you cannot cross. Similarly, the observable universe has borders that we have learned to measure and understand. But have you ever wondered what lies beyond those borders? Human curiosity knows no bounds, and in our eagerness to understand, we have reached the most remote corner of the cosmos. The expansion of the universe is another aspect that deeply intrigues us. Imagine a balloon inflating. As it expands, the points drawn on its surface move away from each other. This is how the universe is. Since the moment of the Big Bang, everything has been in constant motion, moving away in a cosmic ballet. The evidence supporting this expansion is astonishing and reminds us that the cosmos is alive in a state of perpetual change. The large-scale structure of the universe is equally astonishing. Galaxies, those vast conglomerates of stars, group together in clusters and connect through a cosmic web. Imagine a huge loom where each thread represents a galaxy, and together they form an intricate pattern that extends beyond what our eyes can see. This framework leads us to reflect on the place we occupy in this vastness. However, dark matter and energy are two of the great mysteries that still challenge us. Although we cannot see them directly, we know they make up most of the universe. They are often compared to the darkness in a room. Although we cannot see it, its presence is felt and impacts everything around us. What role do they play in the shape of the cosmos? That is a question we have yet to answer. When we talk about the shape of space, we delve into the intriguing world of cosmic geometry. Did you know that the universe could have a shape similar to a sphere or even a donut? The way space curves and folds influences how we perceive distance and movement in the cosmos. This leads us to Einstein's theory of relativity, a radical shift in our understanding of time and space. Black holes, those mysterious objects of the cosmos, are another fascinating topic. Imagine a place in the universe where gravity is so intense that nothing can escape its pull, not even light. The formation of black holes and their role in the structure of the universe leads us to question their nature and how they influence stellar systems. The life cycle of stars is equally fascinating. From their birth in gas clouds to their explosive death as supernovas, stars are the architects of the cosmos. They create the elements that make up everything we know, including ourselves. Reflecting on how stars shape the universe connects us with the essence of our existence. Interactions between galaxies, such as when they collide and merge, are impressive cosmic spectacles. These collisions not only transform the shape of galaxies, but are also catalysts for new stars and planetary systems. The shape of the universe is constantly evolving, and each collision tells a story of infinite transformation. The formation of planets is another crucial aspect of this cosmic narrative. The processes leading to the creation of planetary systems are intrinsically related to the shape and structure of the cosmos. Every planet, every moon, and every asteroid are the results of a cosmic dance that has unfolded over millions of years. The search for extraterrestrial life is also deeply related to the shape of the universe. How does the structure of the cosmos affect the possibility of life on other worlds? This question leads us to explore not only our place in the universe, but also the possibility that we are not alone in this vast expanse of space. As we delve into more complex theories like string theory, we understand that perhaps everything is interconnected. This theory seeks to unify the fundamental forces, suggesting that the cosmos has a more intricate shape than we imagined. And when we combine this with quantum cosmology, we begin to see that the universe is a place where the classical rules do not always apply. Finally, it is essential to reflect on the future of the universe. What does the final destiny of the cosmos hold for us? Theories about how it could evolve and change are as varied as they are intriguing, and each one invites us to think about our role in this endless story. With all this in mind, it is evident that the relationship between humans and the cosmos is profound. Our understanding of the universe not only affects our perception of the world around us, but also our very existence. As we explore and discover more about the shape of the cosmos, we also delve into the discovery of ourselves. Curiosity is a powerful engine, and the desire to understand the universe drives us to keep exploring. What discoveries await us in the vast and mysterious universe? The search is just beginning. The observable universe is a fascinating subject that sparks everyone's curiosity. But what does this really mean? Imagine a huge balloon that is slowly inflating. Each point on its surface represents a galaxy, and as the balloon expands, those points move away from each other. This is a basic principle that helps us understand what the observable universe is. It's the part of the cosmos that we can see, measure, and study. The observable universe extends about 900 billion light years in all directions. But how do we know how big it is? The answer lies in the light. When we look at the stars, we are observing light that has travelled for thousands or even millions of years to reach us. So when we look at the sky, we are seeing a kind of time capsule. But what about the boundaries? If the universe is so vast, does it have an end? The answer is a bit more complicated than it seems. Some theories suggest that the universe is infinite, while others indicate that it could be limited, although we will never be able to reach it. The expansion of the universe, which begins with the Big Bang, implies that everything that exists is moving away from us, which makes the concept of boundary even more intriguing. How can something that is constantly expanding be measured? Astronomers use techniques such as the redshift of light to determine the speed at which galaxies are moving away. This phenomenon is like hearing the sound of a siren moving away. As the sound moves away, its pitch changes. Now let's think about how this vast observable universe was formed. It all started about 14 billion years ago, when a singularity, a point of infinite density, exploded in what we know as the Big Bang. From that moment, space and time began to expand, creating everything we know. But what happened next? The first atoms were formed, and with them, the matter that would eventually give rise to stars and galaxies. In this process, galaxies are not just clusters of stars. Imagine a huge ocean, where each drop of water represents a star. Galaxies are like waves that form as the water moves. Some galaxies are more densely clustered, forming clusters, while others are alone in the vast cosmic ocean. The beauty of the observable universe lies in this diversity, and how each component interacts with each other. The distance to which we can see in the universe is also limited by the time that has passed since the Big Bang. This means that the further we look, the further back in time we travel. However, this raises another question. What is beyond what we can observe? Are there other regions of the universe that we will never be able to see? Perhaps, but that does not stop us in our quest to understand what is around us. Every new star that is born, every galaxy that is formed, contributes to the story of the cosmos. The matter that makes up the observable universe is just a part of a much larger narrative. The search for answers about the universe leads us to question the very nature of reality. Is everything we see just the tip of the iceberg? For scientists, this is a field full of mystery and discovery. Astronomy, physics, and cosmology work together to unravel the secrets of the observable universe. Every telescope, every satellite, and every space mission brings us a little closer to the truth. But how can we be sure of what we have discovered? The answer lies in repetition and verification. What once seemed like a simple flash of light in the sky can become a deep object of study. Scientists not only observe, they also generate theories, conduct experiments, and make calculations, always ready to revise their ideas as new data emerges. This methodical approach is what allows our understanding of the universe to continue evolving. In the end, the observable universe is not just a subject of study, it's a reflection of our innate curiosity. Each question we ask opens the door to new explorations and discoveries. The magnitude of the cosmos invites us to dream, to imagine what might exist beyond our reach. In a way, each of us is part of this universal story, seeking to understand our place in a vast cosmic stage. So the next time you look up at the starry sky, remember that you're not just looking at stars, you're contemplating the observable universe, a place full of mysteries where each twinkling light tells a story of distant times. The search for the truth about this cosmos teaches us that, although we may feel small in its immensity, our questions are big and worthy of exploration. The story of the universe begins with an explosive moment, known as the Big Bang. But what does this really mean? Imagine a deflated balloon. When you inflate it, you see how it expands and fills with air. Just like that balloon, the universe began at an extremely small point, and from that moment has been constantly growing. Since then, galaxies, stars, and planets have been forming a vast and complex cosmic fabric. What is the secret behind this expansion? To understand it, it is essential to know that it is not just about galaxies moving away from each other. In reality, space itself is expanding. It's as if the universe were a gigantic network of points that are separating more and more as time progresses. This phenomenon was discovered by astronomer Edwin Hubble in the 1920s, who observed that galaxies were moving away from each other, and that the farther away they were, the faster they moved. This is what we call Hubble's law. In simple terms, the expansion of the universe does not imply that galaxies are moving through empty space, but that space itself is stretching. This may seem a bit confusing, but think about raisins inside a balloon. As you inflate the balloon, the raisins move away from each other. This is how the universe works. The space between galaxies expands, and that causes them to move away from each other. The Big Bang theory is not just a brilliant idea, but it is backed by solid scientific evidence. One of the most compelling pieces of evidence is the cosmic background radiation, a kind of echo of the Big Bang. This radiation is a remnant of the light that was generated in the early moments of the universe and is still travelling through the cosmos. Scientists have detected it in all directions, and its temperature is almost uniform, suggesting that the universe has been cooling since its initial explosion. But how do we know that the universe will continue to expand? The answer lies in the observation of supernovas. When a massive star reaches the end of its life, it explodes in a brilliant explosion known as a supernova. By observing these explosions in distant galaxies, astronomers have noticed that the light from some supernovas is dimmer than expected. This indicates that the galaxies are moving away faster than previously thought, suggesting that the expansion of the universe is accelerating. But what drives this acceleration? This is where more mysterious concepts like dark energy come into play, which is believed to make up about 70% of the universe. Although we do not fully understand what it is thought to act as a repulsive force that pushes galaxies even further away as the universe expands. Imagine an invisible force that, instead of attracting, pushes everything outward. That is dark energy, an enigma that scientists are eager to solve. The expansion of the universe also poses a fascinating question. What will the cosmos look like in the future? As the universe continues to expand, the galaxies we see today could move so far away that they become invisible. This is because the light they emit would take longer to reach us than the time that has passed since they began to move away. It's a disturbing scenario where the universe would become a lonely place, full of invisible galaxies. Some cosmologists suggest that this expansion could lead to a future where the universe gradually cools down in an event known as the Big Freeze. In this scenario, the stars would go out, leaving only a vast dark space. However, other scientists propose the possibility that the expansion of the universe could stop and reverse, leading to a big crunch, where everything would collapse into a tiny point once again. These theories show us how uncertain and exciting our place in the cosmos is. On this journey through time and space, it is fascinating to think about how the expansion of the universe affects our understanding of life itself. As the cosmos expands, it reminds us of how small we are compared to the vastness of the universe. However, despite our apparent insignificance, our curiosity and desire to understand our surroundings have led us to make amazing discoveries. The expansion of the universe is not just a physical phenomenon. it is also a reminder of our connection with the cosmos. It invites us to reflect on our existence, on how every atom in our body originated in the stars, and how we are made of the same matter that makes up the universe. This perspective encourages us to keep exploring, to ask questions, and to desire to unravel the mysteries that we still have to discover. We can see that the expansion of the universe is, in turn, a journey into the unknown. Each new answer we find generates new questions. Research on the cosmos is like an endless puzzle that challenges us to keep searching and learning. As scientists continue their explorations, the future of the universe will remain a fascinating topic full of surprises. In summary, the expansion of the universe is an amazing phenomenon that not only tells us about the past, but also invites us to imagine the future. It is a reminder that, although the cosmos seems vast and mysterious, our quest for knowledge and understanding is infinite. What discoveries await us on the horizon, and how will they change our view of the universe and ourselves? Only time will tell, but what is certain is that human curiosity will never stop shining, even in the darkness of space. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. What really shapes the cosmos? To understand the vastness of the universe, it is essential to know the large-scale structure that composes it. From the tiniest group of stars to the vast clusters of galaxies, each of these elements plays a fundamental role in the orchestration of the cosmos. But how do they relate to each other, and how have they come to be in the arrangement we see today? Let's consider the galaxies. These gigantic collections of stars, gas and dust are like islands in a cosmic ocean. In the context of our universe, there are billions of galaxies. The Milky Way, our own galaxy, is just one of them. But what shape do these galaxies have? Some are spirals, like ours, others are elliptical, and some even have irregular shapes. Each type of galaxy has its own history and unique characteristics. Now, what about galaxy clusters? Imagine that galaxies are like small bubbles in a liquid. When we look at large scale, we can see that these bubbles group together into clusters. These clusters are huge, containing hundreds or thousands of galaxies. Moreover, sometimes these clusters are not alone. They organize into superclusters, forming a cosmic network that resembles an intricate loom of matter. How are these colossal structures formed, and what force keeps them together? Gravity is the invisible thread that weaves this network. It is the force that attracts galaxies to each other and allows larger structures to remain cohesive. However, gravity does not act alone. Alongside it, there are other components, such as dark matter, which we cannot see but plays a crucial role in this cosmic dance. What exactly is dark matter, and why is it so important to the structure of the universe? Dark matter is a type of matter that does not emit light or energy, making it invisible to us. However, we know it exists thanks to its gravitational influence. If we look at a cluster of galaxies, we can see how the galaxies within it move. Their speed suggests that there is more mass present than we can observe. This extra mass is what we call dark matter. Without it, galaxy clusters would collapse like a house of cards. As we move away and begin to observe the larger cosmic network, we notice that the universe is not a homogeneous place. There are immense voids between galaxies and clusters, as if the cosmos were woven with threads and empty spaces. Why is this so? These voids are the result of the expansion of the universe and how matter has been distributed over time. As the universe expands, galaxies move away from each other, creating these vast uninhabited regions. The shape of the cosmic structure also raises intriguing questions about the nature of the universe itself. Is it really finite or infinite? If we could travel through the cosmos, where would our journey take us? Some scientists suggest that the universe is flat, while others believe it could be curved, like the surface of a sphere. This geometry affects how we perceive distance and time on a large scale. As we explore these structures, we must also consider the role they play in the history of the universe. Galaxies are not static entities. They are constantly moving and evolving. Interactions between them, such as the merging of galaxies, can give rise to new shapes and structures. What would happen if two galaxies encountered each other? The result could be a massive elliptical galaxy, a new type of galaxy that did not exist before. It is fascinating to think about how these interactions shape the cosmos. Each collision and merger of galaxies is an event that can shape the structure of the universe for billions of years. The history of our universe is written in the trajectories of these galaxies. What stories would they tell if they could speak? All of this leads us to a deeper reflection on the cosmos. Every star we see in the sky, every galaxy we observe through powerful telescopes is a testament to the complexity and beauty of the universe. The shape of the cosmos is not only a subject of scientific study, but also a source of inspiration and awe. In the end, the large-scale structure of the universe is a fascinating mix of beauty, chaos, and order. As we continue to explore and discover more about the cosmos, we not only learn about the universe, but also about ourselves and our place in this vast framework. The shape of the cosmos is a reminder that no matter how small we may be, we are all part of something much larger. What is that thing present in almost the entire universe that we cannot see? Often, when we think of the cosmos, we imagine bright stars, planets, and galaxies. But surprise, there is something even more intriguing that makes up almost 95% of the universe. Dark matter and dark energy. What are they and why are they so important? Let's start with dark matter. Although we cannot see or touch it, we know it's there, like a ghost influencing everything we know. Imagine that you are at a party at a friend's house. The lights are off, but you feel someone gently pushing a table. You can't see the person, but you can feel their impact. That's how dark matter works in the universe. Through its gravity, it affects galaxies and clusters of galaxies, keeping them together. Without this mysterious matter, the stars would scatter and structures as we know them would not exist. Now, how do we know that dark matter exists if we cannot observe it directly? Scientists have observed how galaxies rotate. If there were only the matter we can see, the galaxies would rotate at a speed that would make them crumble. However, galaxies rotate much faster than expected. This behavior suggests that there is a large amount of invisible mass that is keeping everything in place. Isn't it fascinating to think that such a large part of the universe is hidden from our eyes? Moving on to dark energy, it is even more enigmatic. It could be described as a mysterious force that is accelerating the expansion of the universe. Think of a balloon being inflated. At first, it expands slowly, but as you add more air, it begins to expand faster. Dark energy acts similarly, pushing the universe to expand faster and faster. But what is this force driving the cosmos towards infinity? Scientists have tried to unravel the mystery of dark energy since it was discovered that the universe was expanding. Observations of distant supernovas have shown that it not only expands but does so at an accelerated rate. This finding surprised the scientific community and raised the question: what is causing this acceleration? Theories are varied, but no consensus has been reached. Some suggest that dark energy is a property of space itself, while others propose that it could be a new form of energy. Can you imagine living in a universe where gravity was the only force affecting galaxies? Without a doubt, the cosmos would be a very different place. The presence of dark matter and dark energy transforms our understanding of the universe. If we removed this as mysteries, the cosmos we know would crumble, leaving a void that we could barely understand. The search for answers about dark matter and dark energy has led scientists to develop increasingly complex theories. Some propose that dark matter could be composed of yet undiscovered particles like WIMPs, which stands for weakly interacting massive particles. But what does that really mean? In simple terms, they are particles that barely interact with normal matter, making them almost undetectable. Meanwhile, dark energy has become an enigma that defies our intuition. The idea that something could be pushing the universe towards expansion is almost surreal. But what is even more intriguing is that dark energy could be related to the cosmological constant, an idea that Einstein proposed in his famous equation of relativity. When considering dark matter and dark energy, it is clear that they are not only parts of the cosmic puzzle, but are fundamental pieces that determine the shape and destiny of the universe. The way these forces interact could define whether the universe will continue to expand forever, or if it will eventually contract into what some call the Big Crunch. The mystery of what makes up this vast universe is a reminder of how little we truly know. It makes us feel humble in the face of the immensity of the cosmos and invites us to keep searching for answers. It is a constantly evolving field of study, full of theories that challenge our understanding and invite curiosity. Dark matter and dark energy are not just abstract concepts. They are the key to understanding the structure of the universe. Each discovery we make about them brings us one step closer to unraveling the mystery of how the cosmos was formed and where it is heading. The exploration of these mysterious forces is undoubtedly one of the greatest challenges of modern science. So the next time you look at the starry sky, remember that beyond the bright lights and visible planets, there is a universe full of secrets. Dark matter and dark energy are just the beginning of a story that is still being written. The search for these components of the universe is an adventure that connects us all, pushing us to look beyond what we know and wonder about what is still to be discovered. The shape of space is a fascinating concept that invites us to think beyond what we see at first glance. Have you ever wondered if the universe is flat, curved, or has some strange and unknown shape? The answer to this question is not only intriguing, but also has profound implications on how we understand everything around us. The geometry of the universe may seem like an abstract topic, but it is fundamental to deciphering the behavior of the cosmos as a whole. When we talk about the shape of the universe, we refer to the way galaxies are distributed and the structure of space itself. Imagine you're in a vast ocean, and each galaxy is an island. But what shape does this ocean have? The answer is related to the curvature of space. If the ocean is flat, then the islands are distributed evenly. If it is curved, some islands may be closer to each other, forming groups, while others may be separated by vast stretches of water. The shape of the cosmos can be understood through three possibilities: a flat universe, an open one, and a closed one. A flat universe resembles a completely leveled surface, where parallel lines never meet. In an open universe, lines eventually separate, as if you were on a surface that extends infinitely. On the other hand, a closed universe is like the surface of a sphere, where lines eventually cross and meet, forming a cycle. How can we determine which of these shapes is correct? Scientists have used various tools, such as the cosmic microwave background, a residual radiation from the Big Bang, to measure the curvature of the universe. This background acts as a kind of echo from the past, allowing us to glimpse what the universe was like in its early moments. From these measurements, astrophysicists have found that the universe is surprisingly almost perfectly flat. But what does that mean for us? A flat universe implies that the amount of matter and energy in it is exactly what is needed for the expansion of the cosmos to balance with gravity. If there was more matter, the universe would collapse on itself. If there was less, it would continue to expand forever. This delicate balance is like a tightrope on which our cosmos is situated, maintaining a balance between expansion and gravity. But what about the shape of space on smaller scales? In our everyday experience, space appears to be three-dimensional, but in reality, our universe has a much more complex structure. Einstein's general relativity teaches us that gravity not only affects matter, but also curves space itself. Imagine placing a heavy ball on a trampoline. The surface sinks and deforms. Thus, large masses like black holes and galaxies shape the fabric of space around them. The idea that space can be curved may seem strange, but it is essential to understand phenomena like the light of stars that bends when passing near a massive object. This phenomenon, known as gravitational lensing, allows us to observe distant objects that we otherwise could not see. It's as if the universe were playing a game of cosmic mirrors, reflecting the light of stars through the curvature of space. As we explore further, it becomes evident that the shape of the universe is not just a matter of academic curiosity. It has repercussions on the way we understand the history of the cosmos and its future. Are we destined for a final collapse or infinite expansion? The answer could depend on the shape of space and the amount of dark matter and dark energy it contains. Furthermore, the shape of the cosmos also influences the way we travel through it. If space is flat, our trajectories are more predictable and linear. But if it is curved, our routes can be much more complex, affecting the way we move in the universe and how we interact with other celestial bodies. It is fascinating to think that despite our apparent insignificance in the vastness of the cosmos, our quest to understand the shape of the universe connects us with the very fabric of reality. Each discovery about the geometry of space not only brings us closer to the truth about our cosmic home, but also invites us to reflect on the place we occupy in this vast stage. Finally, the shape of the universe is a reminder that there is much more to discover. As technology advances and our observation methods become more sophisticated, it is likely that we will obtain even more surprising answers about the nature of the cosmos. The exploration of the structure of the universe is not just a quest for knowledge, but also a journey towards understanding our own existence. And so, the next time you look at the starry sky, remember that you are observing a vast ocean of possibilities, where the shape of the cosmos remains one of the great mysteries to be solved. The theory of relativity is one of the key pieces that revolutionized our understanding of the universe. How is it possible that something as abstract as time and space intertwine in such a way that they change our view of the cosmos? The answer lies in the brilliant ideas of Albert Einstein, who at the beginning of the 20th century offered us a new way of understanding reality. Relativity is based on two fundamental principles. First, the laws of physics are the same for all observers, regardless of their speed. That is, if you're on a high-speed moving train and you throw a ball forward, the ball will behave in the same way as if you were standing at the station. But what happens when we talk about gravity? This is where the second principle comes into play. The presence of mass deforms the space and time around it. Imagine that space is a large stretched sheet. Place a heavy ball in the center, and you will see how the sheet curves. This curvature is what we experience as gravity. This image of the sheet helps us visualize how planets, stars, and black holes affect the environment around them. When a massive object is in space, it not only attracts other objects, but also modifies the path they will follow. For example, the Earth does not only revolve around the Sun because it is being attracted by its gravity, but because space itself is curved by the mass of the Sun. This is the heart of general relativity, which teaches us that space and time are flexible, not solid. But how does all this relate to time? Relativity tells us that time is not a universal constant. Imagine two twins. One stays on Earth while the other travels in a spaceship at a speed close to that of light. When the traveling twin returns, he realizes that he has aged less than his brother. This phenomenon is known as time dilation and is one of the most surprising predictions of relativity. In other words, time does not run the same for everyone. Now, let's think about black holes. These are perhaps the most fascinating objects in the universe. They form when a massive star exhausts its fuel and collapses under its own gravity. The curvature of space and time inside is so intense that nothing, not even light, can escape its attraction. This means that when we look at a black hole, we are actually observing a void in space, a place where time and space behave strangely. Black holes are not only devourers of matter, They also play a crucial role in the evolution of galaxies. Their influence can affect the formation of new stars and the dynamics of entire galaxies. What does this mean for us? That despite how distant it may seem, relativity and black holes are intertwined with our own existence. Relativity also provides us with a framework for understanding the universe on a large scale. It helps us explain the expansion of the cosmos and how galaxies move away from each other. If time and space are flexible, then the universe itself is in constant change and movement. Every galaxy, every star, every planet is on a continuous journey through a space that never stops transforming. However, this is not just a matter of movement. Relativity also invites us to reflect on the nature of space itself. If space can curve and bend, then what happens if there are more dimensions than we perceive? Some theories suggest that there could be additional dimensions that we cannot see, which adds a layer of complexity to our understanding of the cosmos. As we delve deeper into relativity, we encounter questions that challenge our intuition. Is it possible to travel in time? How does our perception of time relate to the reality of the universe? These questions have no simple answers, but relativity offers us clues about the nature of time and space that continue to intrigue scientists and philosophers alike. In addition, relativity is not limited to theoretical physics. It has practical applications in our daily life. For example, global positioning systems or GPS must take into account the effects of relativity to provide accurate locations. Without relativity, our modern technologies would work very differently. In the quest to understand the cosmos, the theory of relativity is a beacon that illuminates the path. It teaches us that the universe is a surprisingly complex and beautiful place, where the rules we think we know can be challenged. Every discovery we make about relativity not only brings us closer to understanding the cosmos, but also invites us to contemplate our place in it. Einstein's relativity is more than a theory. It is an invitation to explore the unknown, to question what we believe we know, and to marvel at the vastness of the universe. As we continue to explore the depths of the cosmos, it is essential to remember that every question we ask about time and space brings us a little closer to unraveling the mystery of existence itself. Black holes are one of the most fascinating and enigmatic phenomena in the universe, but what exactly are they? In simple terms, a black hole is a region of space where gravity is so intense that nothing, not even light, can escape its pull. This means they are invisible to us. However, their presence can be inferred through their effects on nearby objects. Imagine a trap that once activated closes all exits. This is how black holes work. They create a gravitational field so strong that anything that gets too close is irretrievably trapped. When a massive star exhausts its fuel, its core collapses under its own gravity, creating a black hole. This process is like a giant shrinking down to become a tiny point where all its mass is concentrated. But what happens inside a black hole? The answer to this question is extremely intriguing. Upon crossing the event horizon, which is the point of no return, you enter a world where the laws of physics as we know them cease to apply. At this point, time and space distort in ways we do not fully understand. It's as if you've crossed a door into a place where the rules are completely different. The nature of black holes has led many scientists to wonder, could they be portals to other places in the universe? Although the idea sounds like science fiction, there are theories suggesting that there could be connections between black holes and other regions of the cosmos. However, for now, this remains in the realm of speculation, as there is no concrete evidence to support it. A fascinating aspect of black holes is their ability to eat matter. When a star or gas approaches a black hole, it starts to spin around it, forming a disk of material known as an accretion disk. This material heats up to extreme temperatures due to friction and emits intense radiation, which often allows astronomers to detect the presence of a black hole, even if they cannot see it directly. Now, why should we care about black holes? The answer is simple. They play a crucial role in the structure of the universe. They are found at the center of most galaxies, including our Milky Way. It is believed that their gravitational influence helps to hold stars and other celestial bodies together. So, although they may seem like dark and terrifying objects, they are fundamental to the organization of the cosmos. Black holes also teach us about the nature of time and space. As an object approaches a black hole, time appears to slow down for it compared to a distant observer. This phenomenon, known as time dilation, is one of the most surprising predictions of Einstein's theory of relativity. Imagine being on a spaceship watching time pass more slowly as you approach a black hole. For you, it might seem like only a few minutes have passed, while for someone on Earth, years may have gone by. Some black holes are truly monstrous, known as supermassive black holes. They are found at the center of galaxies and can have millions or even billions of times the mass of the Sun. Their origin is a mystery. How is it possible for such titans to form? Some theories suggest they could have grown from smaller black holes through mergers and the accumulation of matter for billions of years. As scientists continue to study these mysterious objects, they have begun to discover that not all black holes are the same. There are black holes of different sizes and origins. Stellar black holes, for example, are the result of the collapse of massive stars, while others may form from the merger of stars in binary systems. Each type of black hole offers clues about the history of the universe. Research on black holes has also led to advances in understanding fundamental physics. The search for a theory that unifies general relativity and quantum mechanics has led to considerations of how black holes behave in the context of quantum physics. Could there be information that is lost in a black hole? This dilemma has challenged scientists and sparked passionate debates in the scientific community. In the field of observation, the Event Horizon Telescope made history by capturing the first image of a black hole in 2019. This image of the black hole at the center of the M87 galaxy was a milestone in astronomy, providing visual evidence of its existence and opening new doors for research. The possibility of observing these phenomena brings us a little closer to unraveling their secrets. But beyond being objects of study, black holes also invite us to reflect on our own existence. They represent the limits of our knowledge and remind us of how little we know about the universe we inhabit. By exploring these mysterious remnants, we find ourselves at the frontier between science and philosophy, questioning our understanding of time, space, and reality itself. Human curiosity drives us to understand the unknown, and black holes are one of the many open questions in the vast book of the cosmos. Each discovery brings us a little closer to unveiling the secrets of the universe, and each answer leads us to new questions. On this journey into the unknown, black holes are one of the most intriguing stops, reminding us that despite our intelligence, there will always be mysteries that challenge us and motivate us to keep exploring. The life of stars is a fascinating phenomenon that directly connects us to the universe. Have you ever wondered how these gigantic spheres of plasma are born, live, and die? Stars are more than just points of light in the sky. They are cosmic factories that create the elements that make up everything we know, including ourselves. But what is the life cycle of a star? To understand it, we must first imagine a vast cloud of gas and dust in space. This cloud, known as a nebula, is where our story begins. At the heart of this nebula, gas particles begin to attract each other due to the force of gravity. As they group together, the pressure and temperature increase, forming a hot core. This process is similar to when you knead a ball of dough. The more you squeeze it, the more heat it generates. Eventually, this core will reach such high temperatures that nuclear fusion, the process that gives life to a star, is triggered. When a star enters the fusion phase, it begins to shine. But what does that really mean? Nuclear fusion is the process in which the nuclei of atoms combine to form new elements. In the early stages of their life, stars convert hydrogen into helium. It's like having an oven in which the ingredients are transformed into a delicious dish. But this phase doesn't last forever, and eventually the hydrogen runs out. So, what happens next? When the hydrogen is depleted, the star enters a new stage of its life. It begins to fuse helium into heavier elements such as carbon and oxygen. As these new elements are created, the star expands, becoming a red giant. Imagine a bubble inflating until it becomes so large that it seems about to burst. This expansion is a crucial part of a star's life, as it also influences its surroundings. During this phase, the star may experience a series of dramatic events. Sometimes the outer layers of the star peel off, creating a beautiful planetary nebula. These nebulas are like the universe's works of art, composed of bright gases and dust that scatter across space. But what happens to the star's core? Does it survive this explosion? The fate of the core depends on the initial mass of the star. In the case of smaller stars like our Sun, the core turns into a white dwarf, a hot remnant that will eventually fade over time. However, for more massive stars, the end is much more spectacular. They can explode in a supernova, one of the most powerful explosions in the universe. This explosion is so intense that it can outshine an entire galaxy for a short period. But what remains after such a cataclysm? After a supernova, the core can collapse into an extremely dense object known as a neutron star, or, if it's massive enough, it can turn into a black hole. These black holes are like cosmic vacuum cleaners that trap everything that comes near them, even light. Isn't it amazing to think that what was once a shining star can become an object that lets nothing escape? But the life of stars doesn't end with their death. Supernova explosions scatter the heavy elements they have created throughout their lives across space. These elements, like carbon, oxygen, and iron, are fundamental to the formation of new star systems and eventually planets. It's as if each star is contributing to the creation of new generations of celestial bodies. Can you imagine that the atoms in your own body might have been forged in the heart of a distant star? This cycle of birth, life, and death of stars is what shapes our universe. Each star we see in the sky is part of an ongoing story that repeats itself over billions of years. Understanding this cycle not only helps us appreciate the beauty of the cosmos, but it also connects us with the universe's very history. So the next time you look at the stars, remember that each one has its own journey, and that their existence is intimately linked to ours. Stars are, in short, much more than simple lights in the darkness. They are the pillars of creation, the architects of the cosmos, and although their lives are fleeting compared to the vastness of the universe, their legacy endures, fueling the life and evolution of everything we know. Isn't it wonderful to think about the role they play in cosmic history? Did you know that galaxies are like large islands of stars floating in the vast ocean of space? But what happens when these islands get too close to each other? Sometimes, instead of simply passing by, they get caught in a cosmic dance that can completely change their shape and structure. Colliding galaxies are a fascinating phenomenon that shows us how the universe is constantly transforming. Imagine two galaxies that, at first glance, seem to be peacefully sitting in the sky. However, over millions of years, their trajectories lead them to an inevitable encounter. As they get closer, their gravitational forces begin to influence each other like giant magnets. This gravitational tug-of-war can lead to a series of spectacular events. The stars of both galaxies do not collide directly, as they are separated by enormous distances, but their trajectories are altered in surprising ways. When galaxies collide, they not only merge, but can also trigger the formation of new stars. Can you imagine that a violent encounter between two islands can give rise to a new beach full of life? That's how the cosmos works. The interaction between galaxies can compress gas clouds, creating ideal conditions for new stars to be born. This means that, amidst the chaos, stellar life can be reborn. But what about larger structures like galaxy clusters? Imagine a group of friends coming together to form a band. As they join, they can influence each other's styles and rhythms, creating something completely new. Similarly, when several galaxies group together in a cluster, their interactions can give rise to a cosmic network of even larger structures. This helps us understand not only how galaxies form, but also how they connect with each other through space. However, not all collisions result in harmonious mergers. Sometimes galaxies can get caught in a game of push and pull that ends in the destruction of their original shapes. Galaxies can end up stretched, distorted, and in strange shapes, like a candy that has been stretched too much. This deformation process can lead to spectacular structures, like tidal tails, which are streams of stars and gas that extend into space. At this point, an intriguing question arises. What can we learn about the history of the universe through these collisions? Each encounter between galaxies is like a chapter in a cosmic book. By studying the traces left by these interactions, astronomers can reconstruct the evolution of the universe. They tell us stories of how galaxies have changed over time and how they have influenced the structure of the cosmos we see today. A fascinating aspect of these collisions is the role they play in the formation of supermassive black holes. As galaxies merge, matter can concentrate in the center, creating conditions for a giant black hole to form. This black hole in turn can influence the entire galaxy, affecting its shape and the rate at which stars are born and die. It's an endless cycle of creation and destruction that shapes the universe. Moreover, these collisions are not just individual events, they are part of a broader process of cosmic evolution. In the history of the universe, collisions have been fundamental to the formation of the structures we know today. Without them, the cosmos would be a very different place. It would be like an incomplete puzzle, where the pieces do not fit because they have never met. On the other hand, modern technology has allowed us to observe these collisions with incredible detail. Advanced telescopes, like the Hubble Space Telescope, show us images of galaxies that are colliding in real time. These images are like photographs of a cosmic dance that reveals the beauty and complexity of the universe. By observing these interactions, scientists can gather data that helps them better understand the nature of the cosmos. Galaxy collisions also lead us to reflect on our own place in the universe. Each of these interactions takes place on timescales that are hard to imagine. While we live ephemeral lives, the universe unfolds on a time horizon that spans billions of years. This contrast highlights the fleetingness of our existence against the immensity of the cosmos. But what future awaits these galaxies after they collide? Once two galaxies merge, they can start a new life together, forming a larger galaxy. This process, although it may seem chaotic, can also be the beginning of a new era of stability and creation. Thus, each collision is not just an end, but also a new beginning. The next time you look at the night sky, think about the galaxies that are in motion, spinning and dancing in a vast cosmic ballet. Each star you see could be part of a galaxy that has been shaped by the encounter with others, a reminder that, in the universe, nothing is truly still. The shape of the cosmos is a testament to its history filled with collisions, mergers, and constant transformations. Colliding galaxies show us that the universe is a dynamic and lively place, where every interaction tells a story. The beauty of the cosmos lies in its ability to change, adapt, and create, even amidst chaos. So the next time you look at the stars, remember that each point of light could have been part of a monumental event in the history of the universe. The formation of planets is a fascinating process that reminds us how dynamic and amazing the universe is. But how are planets actually born? To understand this, we must travel to the vast and cold regions of nebulae, where everything begins. Imagine a giant cloud of gas and dust in space, a place where gravity acts like a magnet attracting every particle. Over time, this cloud collapses under its own weight, forming what we know as a protoplanetary nebula. In this environment, dust particles begin to collide and join together. Who would have thought that chaos can give rise to creation? As these particles amalgamate, they form small bodies called planetesimals. These are the bricks of the universe. But what happens next? The planetesimals continue to collide with each other, joining their masses and forming larger objects. This process can be violent and messy, but it is crucial for the creation of planets. It's amazing to think that in this environment not only planets are formed, but also moons and asteroids. Gravity, which is the force that keeps us on Earth, acts as the conductor in this cosmic concert. But what determines the shape and size of a planet? The answer lies in the balance between gravity and gas pressure. As a body becomes more massive, its gravity attracts more material, which in turn can make the planet grow and form an atmosphere. Planets are not all the same. Some become gas giants, while others develop as rocky. Why this difference? The planets closer to the Sun, like Mercury, Venus, Earth and Mars, form in a warmer environment, where heavy materials like iron and silicon can condense. In contrast, gas giants like Jupiter and Saturn form in the cold depths of the solar system, where hydrogen and helium can accumulate without restrictions. The creation of a planetary system is not just an individual process, it's a cosmic dance. As the planets form, they begin to influence the environment around them. Their gravity can attract or repel other bodies, shaping the system as a whole. Can you imagine what it would be like to live in a place where planets are constantly in motion, changing their trajectories and shapes? It's like a dance where everyone has a role to play. And speaking of trajectories, this is where asteroids and comets come into play. These minor bodies are remnants of planet formation. Some of them can collide with planets, bringing with them materials that can be crucial for the development of life. In other words, those small bodies that seem harmless can have a monumental impact. Who would say that a small asteroid could be a carrier of life? Planet formation does not end once they have been created. Over millions of years, planets continue to evolve. Plate tectonics on Earth, for example, has shaped continents and oceans. But what about planets in other solar systems? Could they have their own version of plate tectonics? The answer is yes, and scientists are beginning to discover that we are not alone in this cosmic dance. As we explore beyond our solar system, we have found thousands of exoplanets, worlds that orbit distant stars. Some are similar to Earth, while others are completely strange. What does this tell us about planet formation? It shows us that the universe is creative and that there are a multitude of ways in which planets can form and evolve. The search for life on other planets is also closely related to their formation. A planet that is in the habitable zone of its star, where conditions are suitable for life, is more likely to harbour organisms. But how do we know if a planet has those conditions? Astronomers study the atmosphere, composition and distance of these worlds to their stars. Thus, planet formation is not only a physical process, but also a key to understanding if we are alone in the universe. It's interesting to think that by studying how planets form, we are also learning about our own home. The Earth, with its rich diversity of life and landscapes, is the result of billions of years of cosmic history. Every mountain, ocean, and continent tells a story of its own formation. So, the next time you look at the starry sky, remember that each star may be surrounded by its own planets, each with its own story to tell. The process of planetary formation is a reminder of the complexity of the cosmos and how, amidst chaos, order can arise. Every planet, every moon, every asteroid is part of a vast and beautiful spectacle. As we continue to explore and discover more about the universe, each answer also raises new questions. What else awaits us in the vastness of space? What secrets will the formation of new worlds reveal? Human curiosity is insatiable, and the cosmos is full of mysteries waiting to be unraveled. What would happen if we discovered that the universe is not alone? The possibility of extraterrestrial life has fascinated humanity since time immemorial. As we explore the vast expanse of the cosmos, we are faced with an intriguing question. Are we alone in the universe? The shape of the cosmos, with its countless stars and planets, invites us to reflect on this issue and consider the implications of the existence of life beyond our small home, Earth. Since ancient times, we have looked at the night sky, wondering if other civilizations could be looking back at us. The stars we see are just a small fraction of what exists in our universe, and each of them could have planetary systems similar to ours. But what conditions are necessary for life to arise? Is it possible that in some remote corner of the galaxy there are beings who wonder the same about us? The concept of the habitable zone refers to the region around a star where conditions could be suitable for life as we know it. This zone is not a fixed place, but moves depending on the characteristics of each star. Imagine that each star is like a lamp in a room, and the habitable zone is the part of that room where the light is sufficient for plants to grow. Outside of that area, conditions could be too extreme, either due to the cold of deep space or the scorching heat of a nearby star. Advances in astronomy have led to the discovery of thousands of exoplanets, worlds that orbit other stars. Some of these planets are in the habitable zone of their respective stars, which increases the possibility of life. But how do we know if there is life there? The answer to this question lies in the search for biomarkers, signals that would indicate the presence of life on these distant worlds. The search for life is not limited to Earth-like planets. Scientists have begun to explore the moons of our solar system, such as Europa and Enceladus, which have oceans of liquid water beneath their icy surfaces. It has been hypothesized that, just like on Earth, microbial life could exist in these environments. Imagine a hidden ocean full of life, waiting to be discovered. Radio astronomers have also been on the lookout for signals of extraterrestrial intelligence. Through projects like SETI, the search for extraterrestrial intelligence, millions of radio frequencies have been scanned for patterns that cannot be explained by natural phenomena. Although so far we have found no conclusive evidence, the mere fact that we are listening is an important step in our search. The question of whether we are alone in the universe has profound philosophical and scientific implications. If we find life, would it change our perspective on ourselves and our place in the cosmos? It could be the beginning of a new chapter in human history. However, we must also consider what it would mean to make contact with another civilization. Human history is full of encounters between cultures, and they have not always been peaceful. Furthermore, the shape of the universe can also influence the possibility of life. The distribution of galaxies and the large-scale structure of the cosmos create an environment in which certain areas are more likely to harbour life. Dark matter and dark energy, which make up much of the universe, also play a role in the formation of galaxies and star systems. Everything is interconnected. and each element of the cosmos can contribute to the conditions that allow life. As we reflect on the shape of the cosmos, it is also essential to consider how our search for extraterrestrial life has led us to question our own existence. Studying the universe gives us a deeper understanding of ourselves. While the stars may seem distant and unreachable, each discovery brings us a little closer to the answer of whether we are alone in the vast ocean of the cosmos. Science, philosophy, and space exploration are united in this quest for knowledge. Projects like the James Webb Space Telescope not only allow us to see further in time and space, but also help us better understand the context in which life could exist. With each new discovery, we expand our horizon and get closer to understanding the shape of the cosmos and its relationship with life. Extraterrestrial life, whether in the form of microorganisms on a frozen moon or advanced civilizations in distant systems, is not just a concept of science fiction. It is a very real possibility that invites us to keep exploring. As we look up at the sky, we should remember that each star could harbour stories, dreams, and forms of life that we have not yet imagined. So the next time you look at the stars, think about the vastness of the cosmos and the infinite possibilities that could be out there. The search for life in the universe is not just a matter of finding other beings. It is a journey towards knowledge that could redefine our existence and our place in the grand scheme of the cosmos. The shape of the universe is a mystery that, although we have not yet fully solved, drives us to keep exploring and asking. Who knows what wonders the future will bring? String theory is one of those fascinating ideas that seem to be taken from a science fiction novel, but in reality, it is at the centre of current scientific research. Imagine that the universe is not made up of individual particles like the atoms and electrons we all know, but at its deepest essence, it is composed of tiny vibrating strings. These strings are so small that we couldn't see them even with the best microscope in the world. But how could such small strings influence everything we see around us? The strings vibrate at different frequencies, a bit like the strings of a violin. Each vibration frequency corresponds to a different particle. So, when we talk about electrons, quarks, or even the particles that make up light, we are actually talking about different modes of vibration of these strings. Isn't it incredible to think that all the matter that makes up the universe could just be the result of these vibrations? String theory not only seeks to explain subatomic particles, but it also tries to unify all the fundamental forces of nature. We currently know 4 forces: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Can you imagine if we could understand how they all relate in a single theoretical framework? That is precisely what string theory aims to do. It's as if we wanted to piece together a giant puzzle that has been scattered throughout the universe. However, this theory comes at a cost. For it to work, it suggests that there are additional dimensions beyond the 3 spatial and 1 temporal dimensions we perceive. In total, string theory postulates the existence of 10 and even 11 dimensions in some versions. How can we imagine something we can't see or experience? A useful analogy is to think of a garden hose. From afar, it appears to have only 2 dimensions, but if you get closer, you can see that it has a 3rd dimension: its thickness. Thus, the additional dimensions could be rolled up and not visible to us. But why should we care about these strings and additional dimensions? The answer is that, if string theory is correct, it could provide answers to some of the deepest questions we ask about the universe. What happened before the Big Bang? What is gravity at a quantum level? Connecting gravity with quantum mechanics could revolutionize our understanding of physics. In the world of cosmology, string theory also has fascinating implications. It could explain phenomena like dark energy, that mysterious force that seems to be accelerating the expansion of the universe. By better understanding how these strings work, we could unravel the nature of this energy that makes up most of the cosmos. In addition, string theory could be the path to understanding the multiverse, the idea that there are other universes beyond ours. Each of these universes could have its own physical laws and dimensions, creating an infinite variety of realities. Isn't it mind-boggling to think that we could just be one of many possible universes? However, string theory is not without criticism. Some scientists argue that it has not been possible to carry out experiments that confirm it directly. Often, theories in science require empirical evidence to be accepted, and so far string theory has largely remained in the realm of abstract mathematics. This raises the question, is a theory really scientific if it can't be tested? One of the most intriguing features of string theory is its ability to flirt with philosophy. It raises questions about the nature of reality, time, and space. If strings really make up everything we see, then what does it mean to be real? This is a question that has fascinated philosophers and scientists alike for centuries. As scientists continue to investigate and refine string theory, new ideas and approaches are being developed. Some emerging theories are beginning to merge concepts from string theory with quantum mechanics, which could lead to new revelations about the workings of the universe. The search for a unified theory could be the next big breakthrough in our understanding of the cosmos. Although string theory remains a theoretical concept, its appeal lies in its ability to inspire curiosity and wonder about the universe. Each new research and each new discovery brings us closer to unraveling the mysteries of reality. So the next time you look at the starry sky, think about the vibrating strings that could be behind everything you see, tying everything together in a cosmic symphony of wonder and mystery. In summary, string theory is a promising and complex idea that seeks to unite the fundamental forces and explain the nature of the universe. Although there is still much to discover and prove, its exploration leads us to reflect on our existence in a cosmos much vaster and more mysterious than we ever imagined. The search for this understanding is an exciting journey that continues to challenge our minds and expand our knowledge boundaries. Quantum cosmology is a fascinating crossroads where quantum mechanics, which describes the behavior of the smallest things, and cosmology, which deals with the largest, meet. How is it possible that two such different worlds can be connected? In this maze of ideas, we can find answers to some of the most intriguing questions about the universe. Quantum mechanics, often described as the realm of the strange and non-intuitive, tells us that subatomic particles, like electrons and photons, do not have defined characteristics until they are observed. In other words, only by looking at something do we shape its reality. This may sound strange, but imagine you're at a party and you don't know where your friend is. Until you find him, his location is uncertain. He could be anywhere in the room. The same applies to particles at the quantum level. So what happens when we try to apply these principles to the vastness of the universe? Quantum cosmology ventures into this territory, suggesting that the very structure of space and time could be influenced by these quantum behaviors. Think of the universe as a huge ocean where each drop of water represents a particle. As the drops move, the waves created by their interaction can change the shape of the ocean. Thus, particles, through their quantum interactions, could be shaping the structure of the cosmos we see. An intriguing topic that arises from this fusion of ideas is the concept of the multiverse. If in the quantum world every possibility can exist simultaneously, could there be parallel universes, each with its own version of reality? Imagine a book where each page represents a different universe. Each decision you make while reading could lead you down a different path. In the context of quantum cosmology, each choice of a particle could be creating a new branch of reality. The idea that space and time are not fixed but can be shaped by energy and matter is also fascinating. In this sense, the universe is not a static stage. It's more like a canvas that is constantly being painted as particles move and intertwine. This leads us to think about the very nature of time. In a universe where time is influenced by the quantum, is it possible that the past, present, and future are not as linear as we believe? On the other hand, quantum cosmology also leads us to question the nature of gravity. Gravity, which in our everyday experience seems to be a constant and predictable force, can behave in unexpected ways in the quantum realm. How does gravity behave in the context of particles moving in superposition states, where they can be in multiple places at once? This is a mystery that scientists are still trying to unravel. As we explore these ideas, another question arises. Could we someday unify general relativity and quantum mechanics into a single theory? This would be like finding the magic formula that explains everything in the universe. Such unification would not only change our understanding of the cosmos, but could open the door to new technologies that we can only imagine today. The exploration of quantum cosmology also invites us to reflect on our own existence. If the universe is a fabric of probabilities and possibilities, what place do we occupy in it? We are part of this vast stage, influencing and being influenced by the cosmic dance of particles. Everything we experience, from love to sadness, could be seen as manifestations of the quantum interactions that shape our universe. In this context, the question of whether we are alone in the universe takes on new meaning. If multiple universes exist, could there be other conscious beings in realities we will never get to know? The search for extraterrestrial life is enriched with the idea that our universe is just one among many, each with its own rules and possibilities. Quantum cosmology also suggests that the vacuum is not really empty. At the quantum level, the vacuum is filled with virtual particles that appear and disappear in an instant. This phenomenon challenges our notion of what empty means. If the vacuum is full of quantum activity, could it be that what we consider as nothing plays a fundamental role in the structure of the cosmos? In conclusion, Quantum cosmology shows us that the universe is a place full of mysteries and possibilities. It invites us to reimagine our understanding of reality and to explore the connections between the infinitely small and the infinitely large. Each new idea that emerges in this field not only expands our knowledge, but also connects us more deeply with the cosmos and our place in it. So as we continue to investigate, let's remember that each discovery is like a new page in our cosmic book. Each answer we find leads us to new questions, and in this journey of exploration, curiosity is our best guide. Quantum cosmology offers us a glimpse into a universe that is, in itself, a wonder of complexity and beauty. The idea of a multiverse may seem like something out of a science fiction novel, but in the world of cosmology, it's one of the most fascinating and controversial theories. Imagine that our universe, with its trillions of stars and galaxies, is just one bubble in a vast ocean of bubbles, each representing a different universe. The question that arises is, what's inside those other bubbles? Could they be similar to ours, or are they completely different in physical laws and dimensions? A universe like ours has a set of well-defined characteristics, a certain amount of matter, energy, and the laws of physics that we know. But if we consider the possibility that other universes exist, that opens the door to countless possibilities. There could be universes where gravity is stronger, or where elementary particles have different properties. Can you imagine a place where time flows differently? Or a universe where life as we know it couldn't exist? The idea of multiple universes also raises intriguing questions about the fate of ours. What would happen if our universe collapsed? Some theorists suggest that it could give rise to the creation of a new universe, as if it were an infinite cycle. Therefore, the multiverse is not only a fascinating concept, but it could also provide answers about the origin and evolution of our own cosmos. To better understand this idea, let's think of a large tree. Each branch of the tree represents a different universe. Some branches are thick and strong, while others are thin and fragile. Some may have leaves, symbolizing stars and planets, while others are dry and empty. This analogy helps us visualize how the multiverse might be structured, with universes that can flourish, while others wither in the dark. But how did we come to the conclusion that a multiverse might exist? Quantum mechanics, that strange and fascinating branch of physics, plays a crucial role. At the quantum level, particles seem to exist in multiple states at the same time. This has led some scientists to suggest that each possible outcome of a quantum event could give rise to a different universe. Thus, every decision, every event, could be creating new realities in a vast sea of possibilities. However, the multiverse theory is not without criticism. Many argue that being unable to observe or measure these alternate universes, they cannot be considered scientific. Is it enough for an idea to be intriguing for it to be taken seriously? This debate is fundamental in the philosophy of science and highlights the tensions between what we can observe and what we can imagine. One of the most intriguing questions that arises is, if there are multiple universes, could we ever interact with them? Some theorists suggest that if we could find a way to jump between universes, we could experience entirely different realities. This sounds like the plot of a science fiction movie, but the mathematics behind string theory and other theoretical models are exploring these concepts. Imagine for a moment that every decision you make in your life, from the most trivial to the most significant, creates a new universe. In one reality, you decided to stay at home, while in another, you went to a party that changed your life. Every small change could be giving rise to an alternate universe. This perspective can be both liberating and terrifying. The notion of a multiverse also invites us to question our own existence. If there are infinite versions of ourselves in other universes, what makes us unique? The search for meaning and purpose becomes more complex when we consider that we could be just one variation among many. This reflection can be disconcerting, but it also opens the door to new ways of thinking about our identity and our place in the cosmos. As science advances, multiverse theories are complemented by discoveries in astronomy and physics. Advances in telescopes and observation techniques are allowing scientists to explore the cosmos in ways that were previously unthinkable. Although we are still far from proving the existence of other universes, every new finding about our own universe continues to fuel curiosity about what might be beyond. The idea of the multiverse also intertwines with cosmology and the understanding of the origin of the universe. Some theories suggest that the Big Bang could have been just one of many creation events in a broader context of the multiverse. This view transforms our understanding of time and space, turning them into a more vast and complex fabric than we ever imagined. The multiverse, with all its implications, invites us to dream and to question. It reminds us that despite how much we've learned about the cosmos, there's still a vast unexplored territory. Each answer we find generates new questions, and the multiverse is one of the most intriguing mysteries that challenges us to keep exploring, to keep learning, and to keep imagining. Ultimately, the pursuit of knowledge about the multiverse is not only about understanding the cosmos, but about better understanding our own existence and the place we occupy in this incredible universe. Gravity is one of the most fascinating and powerful forces in the universe. But have you ever wondered how it affects the shape and evolution of the cosmos? To understand it, it is essential to think of gravity not only as a force that attracts objects to each other, but as a curvature of space itself. Imagine the universe as a large stretched sheet. When you place a bowling ball in the center, the sheet sinks, creating a depression. If you now throw small marbles near that depression, you will see how they move towards the bowling ball, following the curvature of the sheet. This is how gravity influences the trajectory of celestial bodies. Gravity not only affects individual objects, but also plays a crucial role in the formation of large-scale structures in the universe. Think about how planets group together in solar systems, or how galaxies form and stay together. All this happens thanks to gravitational force. Without gravity, planets would have no reason to orbit their stars, and stars would not have the force to stay together in galaxies. Gravity is the architect of the cosmos, shaping its shape and structure. But what happens when we talk about gravity on larger scales? When we observe the distribution of galaxies in the universe, we notice that they are not evenly distributed. Some regions are densely populated, while others seem empty. This distribution is not random. It is the result of gravity acting over billions of years. The denser regions exert a stronger gravitational pull, attracting matter and forming clusters of galaxies. It's as if the universe were woven with invisible threads that connect and shape everything it contains. Gravity is also responsible for even more astonishing phenomena such as black holes. Imagine a massive star that has exhausted its nuclear fuel. When this happens, gravity can be so intense that the star collapses on itself, creating a black hole. These objects are so dense that not even light can escape from them, making them invisible and therefore difficult to study. However, we know that black holes have a powerful gravitational effect on their surroundings, affecting the stars and gas around them. Their presence can alter the shape of galaxies, and their study helps us better understand gravity in extreme conditions. In addition to black holes, gravity also manifests in interactions between galaxies. When two galaxies get close enough, their gravity can cause a spectacular cosmic dance. These interactions can lead to galactic mergers, where two galaxies combine to form a new one. But what happens to the shape of galaxies in this process? Often, colliding galaxies not only merge, but can also deform, creating complex and beautiful structures. Gravity acts as a conductor in this cosmic symphony, guiding the movement and evolution of galaxies. But gravity does not stop at the scale of galaxies. At the level of the universe itself, gravity is responsible for the expansion of the cosmos. When we talk about the expansion of the universe, we often think of the Big Bang and how it all started. But did you know that gravity also plays a role in how that expansion behaves? Gravity acts as a force that tries to slow down the expansion, while dark energy, another mysterious component of the universe, seems to be driving that expansion. It's as if the universe were in a constant struggle between two opposing forces, shaping its destiny. Moreover, gravity has an impact on the way we perceive time. According to Einstein's theory of relativity, time is not constant and can be affected by gravity. In places where gravity is more intense, such as near a black hole, time slows down compared to places where gravity is weaker. This relationship between gravity and time is a fascinating reminder of how these forces are intertwined in the fabric of the cosmos. Gravity also influences life on Earth. Without it, our planet could not maintain its atmosphere or allow water to flow. The way we experience the world around us is deeply connected with gravity. From the simple act of walking to the way the oceans move, everything is governed by this fundamental force. Gravity not only shapes the cosmos, but also defines our daily existence. As we explore these interactions, it is important to remember that gravity is a force that connects us all. From the tiny particles that make up our body to the distant galaxies in the universe, gravity is the common thread that ties everything together in a grand cosmic tapestry. It reminds us that, despite our apparent insignificance in the vastness of the universe, we are deeply entwined with it. In summary, gravity is much more than a simple force of attraction. It is a force that shapes the cosmos, influences the evolution of galaxies, and affects our perception of time. From black holes to galactic collisions, gravity is the artist that shapes the structure of the universe. As we continue to explore and learn about the nature of the cosmos, gravity will continue to be a fascinating topic that invites us to reflect on our place in the vast universe. As we keep looking up, let's remember that every star, every galaxy, and every corner of the cosmos is in an eternal dance, guided by the powerful force of gravity. The future of the universe is a topic that arouses the curiosity and awe of many. How will the cosmos be in billions of years? Although we are not fortune tellers, scientists have developed some intriguing theories that attempt to answer this question. Imagine that the universe is like a balloon into which we blow air. As the air enters, the balloon expands. But how far will this expansion go? One of the most popular theories about the fate of the universe is the one that holds that it will continue to expand indefinitely. This idea is based on the observation that galaxies are moving away from each other. It's as if every star and every galaxy were in a race towards distance, leaving behind a vast, empty space. However, what will happen when the balloon's air runs out? What will happen when energy disperses? In this scenario of eternal expansion, eventually the stars will go out. As the universe cools and expands, the stars will exhaust their nuclear fuel and will go out. This could be a gloomy moment where darkness will reign and the universe will become a silent and empty place. But this is not the only possible future. Another theory suggests the possibility that the universe not only expands but can also reintegrate. Can you imagine a cosmic cycle in which, after billions of years of expansion, galaxies begin to approach again? This is the idea of the Big Crunch. In this scenario, the universe would contract like a balloon losing air, colliding everything into a singular point. It's a fascinating idea, but also terrifying. A return to the initial chaos. However, what if the universe behaved in an even stranger way? Some scientists propose the possibility of a big rip. In this scenario, the universe's expansion accelerates to such a point that eventually galaxies, stars, planets, and even atoms would be torn apart. Everything we know could be disintegrated, as if an invisible thread were stretching every corner of the cosmos until there was nothing left. As we reflect on these theories, another intriguing question arises. How does gravity affect these future scenarios? Gravity, that force that keeps our feet on the Earth and makes stars spin in their galaxies, plays a crucial role. If gravity is strong enough, it could slow down the expansion and ultimately cause a collapse. But if dark energy, that mysterious force that drives the universe's acceleration, continues to dominate, the expansion will continue without limits. Imagine that the expansion of the universe is like a car accelerating without brakes. What will happen when there is no more fuel? The answer to this question could be the key to understanding the final fate of the cosmos. Research continues, and each new discovery adds a piece to the puzzle. On this journey towards the future, it is also interesting to consider the role of life. What will happen to us humans amidst all this? If the universe cools and darkens, how will that affect our existence? Science fiction often explores this theme, imagining civilizations seeking refuge in distant worlds or finding ways to survive in a constantly changing universe. The search for answers about the future of the universe is not just an intellectual exercise. It invites us to contemplate our own existence and our place in the cosmos. What legacy will we leave in a universe that could be inhospitable in the future? Science and philosophy intertwine in this reflection, leading us to question not only the fate of the universe, but also the meaning of our own life. As we advance in our exploration of the cosmos, it is essential to remember that each answer generates new questions. Human curiosity is a driver of knowledge. Although we do not have all the answers about the future of the universe, each discovery brings us one step closer to understanding the vast and mysterious reality that surrounds us. Science is advancing by leaps and bounds, and it is possible that in the future theories will be developed that we cannot even imagine today. Each advance offers us a clearer vision of the nature of the universe and its evolution. So, as we explore the mysteries of the cosmos, let's remember that the future of the universe remains a fertile field for research and awe. Finally, the future of the universe is a reminder of our own fragility and the beauty of existence. In a cosmos that could be eternal and unchanging, each moment we live is a flash of light in the darkness. What will we do with our time in this vast universe? The answer is in our hands. The relationship between humans and the cosmos is a fascinating topic that invites reflection. How is it possible that small beings on a blue planet question the meaning of the universe? Since time immemorial, humanity has looked up at the sky, feeling both insignificant and extraordinary when contemplating the stars. This duality leads us to question: are we just an accident in the vast immensity of the cosmos? Or is there a deeper reason behind our existence? When we observe the starry night, each luminous point represents not only a star, but a reminder of what we are: stardust. All the elements that make up our bodies, from the oxygen we breathe to the carbon that forms our cells, were forged in the heart of ancient stars. Isn't it amazing to think that we are part of a cosmic cycle that extends for billions of years? The universe not only provides us with the basic components of life, but also offers us a unique perspective on our place in existence. In a sense, looking at the stars is an act of introspection. It invites us to ask, what does it mean to be human in a vast universe? Science offers us answers but also raises more questions. Each discovery in cosmology makes us question our own nature and purpose even more. Furthermore, the quest to understand the shape of the cosmos brings us closer together. Curiosity about the universe unites us, regardless of our cultural or geographical differences. We all share the same need to understand our environment and to wonder about our origin and destiny. In this sense, the cosmos acts as a mirror reflecting our deepest aspirations and fears. What would happen if we realized that we are all connected by something much larger than ourselves? The way we view the cosmos also influences how we live our daily lives. Reflecting on the immensity of space and time can change our perspective on everyday problems. Often, what concerns us seems insignificant in the face of the vastness of the universe. This understanding can offer us a kind of liberation, an opportunity to leave behind trivial anxieties and focus on what really matters: our relationships, our experiences, and our personal growth. In the midst of this reflection, new questions arise. What about the possibility of life on other worlds? The search for extraterrestrial life is not just a scientific exercise. It is a journey towards understanding our own existence. If we find life on other planets, how would that change our perception of ourselves? The possibility of not being alone in the universe raises questions about the nature of life, intelligence, and connection. Could we learn from other beings, or perhaps even share our own knowledge? Advances in astronomy and space exploration have allowed us to glimpse a universe more complex than we ever imagined. Each new discovery, from exoplanets to mysterious radio signals, brings us a little closer to answering questions that have remained unanswered for centuries. This process of discovery is a constant reminder that the cosmos continues to surprise and challenge our understanding. What surprises does the future hold? As science advances, it is vital to remember that curiosity is not limited to scientists. We all have the capacity to marvel at the universe. The way we interact with the cosmos can inspire us to be better caretakers of our planet. Understanding that we are part of a much larger system can foster a sense of responsibility towards the Earth and future generations. How can we then live more consciously and respectfully? On the other hand, the relationship between humans and the cosmos also translates into a search for meaning. Philosophy and spirituality often intertwine with science in this exploration. Is it possible that understanding the cosmos leads us to a deeper purpose? Perhaps each star in the sky is not just a point of light, but a symbol of the human quest for truth. The stories we tell ourselves about the universe are equally important. Throughout history, myths and legends have emerged to explain the unknown. These narratives have helped us make sense of our existence and find a place in the cosmos. Today, science offers new stories based on data and observations, but the desire to find meaning remains constant. How can we integrate these ancient stories with our current knowledge? As we move towards the future, the question about our place in the universe becomes increasingly relevant. Will we be able to fully understand the shape of the cosmos and our role in it? The search for answers will lead us to explore beyond our solar system towards new worlds and new realities. Human curiosity is a powerful force, and it is this same curiosity that drives us to keep exploring. Finally, the relationship between humans and the cosmos invites us to reflect on humility. In a universe so vast and ancient, it is easy to get lost in the grandeur and feel that our problems are insignificant. However, at the same time, each of us has the potential to make a difference. The way we choose to live, learn, and love can resonate into eternity. What legacy will we leave in this vast cosmos? With each question, with each discovery, we get closer to understanding not only the shape of the universe, but also the way we inhabit it. The relationship between humans and the cosmos is a continuous journey, one that invites us to look up, to question, and to dream. In this vast stage, each of us plays a unique and valuable role. Are you ready to continue exploring and discovering what the universe has to offer? What recent discoveries have shaken our understanding of the cosmos? The answer to this question is fascinating and constantly evolving. As we progress in our exploration of the universe, we encounter findings that challenge what we thought we knew and invite us to reconsider our position in the vast cosmic stage. Recently, astronomers have detected gravitational waves coming from collisions of black holes and neutron stars. This phenomenon, which might seem straight out of a science fiction movie, allows us to hear the universe in a completely new way. Gravitational waves are like the echo of cosmic collisions, a whisper that tells us about cataclysmic events that occurred billions of light years away. Isn't it incredible to think that, through technology, we can capture these echoes and understand more about the nature of space and time? Another discovery that has captured the attention of the scientific community is the finding of exoplanets in habitable zones around stars similar to our Sun. With the help of advanced telescopes, scientists have identified over 5,000 of these distant worlds. Some of them are located in what is known as the habitable zone, where conditions could be suitable for the existence of liquid water. Could it be that, on one of these planets, there are forms of life that we have not yet imagined? The possibility that we are not alone in the universe adds a new dimension to our understanding of the cosmos. Dark matter, which for so long was a mystery, is beginning to reveal its secrets. New studies suggest that this enigmatic substance, which makes up about 25% of the universe, could be composed of yet undetected particles. Recent research has led scientists to theorize about the existence of new types of particles that could be responsible for the gravity we see acting in galaxies. If we manage to capture these particles, could we unravel the mystery of dark matter once and for all? In turn, telescopes have captured stunning images of colliding galaxies, showing cosmic spectacles of lights and shapes that defy imagination. These interactions are not only visually stunning, but also teach us about the evolution of galaxies and the role they play in the formation of the cosmos. What stories do these collisions tell us about the past and future of our universe? The study of dark energy, which represents approximately 70% of the universe, is at the center of scientific attention. This mysterious force seems to be driving the accelerated expansion of the cosmos. Recent research has begun to shed light on its nature, suggesting it could be related to Einstein's cosmological constant. Could it be that this dark energy is the key factor determining the final fate of the universe? In addition, space probes, like the James Webb Space Telescope, have begun to offer images of regions of space that were previously invisible to us. These observations have allowed scientists to study the formation of stars and galaxies in the early universe. The new images are like a time machine showing us what the universe looked like billions of years ago. What secrets will they reveal about our own existence? Artificial intelligence is also playing a key role in modern cosmology. Machine learning algorithms are being used to analyze large volumes of astronomical data, identifying patterns that may not be evident at first glance. Thanks to AI, we can process information more quickly and discover new correlations in the behavior of galaxies and dark matter. What unexpected discoveries will emerge from this collaboration between humans and machines? Another exciting area of research is the search for signals from advanced civilizations. Projects like SETI, Search for Extraterrestrial Intelligence, are using cutting-edge technology to scan the sky for signals that may indicate the existence of intelligent life. With each new advance, the possibility of finding a signal from another civilization becomes more tangible. What implications would that have for our understanding of our place in the universe? We have also witnessed the confirmation of the existence of supermassive black holes at the centre of almost all galaxies. These cosmic giants play a crucial role in galactic dynamics and the evolution of the universe. With each new observation, more is revealed about their behaviour and how they influence large-scale structures. What mysteries are still left for us to discover about these extreme objects? Finally, quantum cosmology is beginning to intertwine with our understanding of the universe. The intersection between quantum mechanics and general relativity is opening new avenues of research that could revolutionize our view of the cosmos. With each new advance in this area, we get a little closer to unraveling the deepest secrets of the universe. What revelations await us on the horizon of physics? In summary, the cosmos is a place full of surprises and mysteries, and each new finding invites us to explore more deeply. As we advance in our quest for knowledge, we not only better understand the universe around us, but we also find ourselves in the process. Human curiosity and this search for answers are what drive us to continue exploring and discovering, and the future of cosmology promises to be as exciting as the discoveries already made. The vastness of the cosmos is an enigma that invites us to reflect. As we have explored the shape of the universe, we have come across questions that challenge our understanding of existence and our place in it. What does the universe really mean to us? Throughout this journey, we have discovered that the shape of the cosmos is not only a subject of scientific study, but also intertwines with our own history as human beings. Every discovery we have tackled reveals a new piece of the cosmic puzzle. From the immensity of the observable universe to the fascinating theories that attempt to explain its origin, we have seen how each answer generates new questions. How does all this relate to our daily life? The connection is deeper than it seems, as our perceptions of time and space are shaped by the same laws that govern the universe. Let's reflect on the expansion of the cosmos. The idea that the universe not only exists but is also moving away from us is astonishing. What implications does this have for our understanding of time and the future? The notion that everything is in constant motion reminds us that we are never in the same place, not even temporarily. This leads us to question whether we will ever reach the limits of the universe, or if, on the contrary, there will always be more beyond what we can see. The large-scale structure of the cosmos with its galaxies and clusters shows us that the universe has an astonishing organization. But why do galaxies group together the way they do? The answer to this question may lead us to understand the invisible forces such as dark matter and dark energy, which make up most of the universe. Although we cannot see them, we know they are there, influencing the shape and evolution of the cosmos. What secrets could they reveal to us if we manage to understand their nature? The geometry of the universe is another intriguing aspect. Is space curved, flat, or does it have a shape that we have not yet imagined? This question is not only mathematical, but also has profound philosophical implications. The shape of space can influence the way we experience reality. Are we destined to understand one day the true shape of the cosmos? The search for answers to these questions leads us to delve into the most complex theories of modern physics. As we explore black holes and the life of stars, we discover that these entities are not only fascinating, but also play a crucial role in the creation of the elements that make up our world? Could it be that, by observing the night sky, we are looking at parts of ourselves? Each star in the firmament has lived and died, leaving its mark on the matter from which we are made. Cataclysmic events such as galaxy collisions show us that the cosmos is a place of constant change. What does this mean for the stability of what we know? The evolution of the universe is marked by transformation, and perhaps that is an important lesson for us. In our daily life, how do we respond to change? Do we fear it or embrace it? The formation of planets and the search for extraterrestrial life are fundamental steps in our exploration of the cosmos. The possibility of other inhabited worlds leads us to wonder about the loneliness of the human being in the universe. Are we really alone? Or are there other civilizations observing from their own perspective? The answer to this question could redefine our understanding of life itself. As we delve into string theories and quantum cosmology, we begin to see the universe as an intricate web of connections. Is it possible that all the fundamental forces are intertwined in a way that we have not yet been able to decipher? Science advances, and each new discovery brings us one step closer to unveiling the complexity of the cosmos. The idea of the multiverse invites us to imagine a cosmos filled with parallel universes, each with its own laws and realities. What would happen if our existence were just one of many? This notion challenges our perception of reality and invites us to question the nature of our own universe. The influence of gravity on the shape and evolution of the universe is undeniable. From the fall of an apple to the dance of the planets, gravity is the force that binds everything. How does this force affect us in our daily life? The answer is simple. We are immersed in its constant embrace. However, what would happen if gravity were not always the same? Finally, when contemplating the future of the universe, we face questions about our own destiny. What will the cosmos be like in 1 billion years? Are there scenarios in which humanity can survive and thrive in a constantly changing universe? These reflections lead us to appreciate the time we have and to value each moment as a part of our cosmic history. The relationship between the human being and the cosmos is a common thread that unites us all. As we continue to explore the mysteries of the universe, let's remember that each discovery not only brings us closer to understanding the cosmos, but also reveals more about ourselves. The search for answers is infinite, and each of us is part of this grand adventure. So let's keep asking, exploring, and marveling at the immensity of the universe, because in every corner of the cosmos there is a bit of us waiting to be discovered.